So we're coming in today looking at finding and approximating square roots. Okay. So, we're looking at finding and approximating square roots. We can find the root of a number by the reverse operation, raising a number to a power. So, for example, the square of 5 squared is 25. We know. Negative 5 squared is 25. Negative 5 squared is negative 25. This is a little anomaly. We'll talk about that later. And we take 1/2 squared. We get 1/4. Okay, this is a little bit of review. But the reverse of this is finding the square root of a number. So if we said the square root of 25 is 5, since 5 times 5 equals 25. Okay. Now, we're thinking about this. This symbol we have, I have talked about this before, but this is called a radical sign. And the number that goes inside of it is called the radicand. So, thinking about this, and if we have an expression with a radical in it, it's a radical expression. So for a square root, let's look at this. I'm going to put square root here. I'm going to look over some different rules type. So if A is positive, so when A is positive, then, okay, so when A is positive, the square root of A is the positive square root of A. So this means this is saying this is the positive square root of A. Okay? Now, negative square root of A, what this means is just said it, but negative square root of A. Okay? Now, and also we should say the square root of 0 is equal to 0. So, that being said, let's look at a few examples of finding square roots here. If we took an instance, we said, what's the square root of 36? Well, we know that should be 6. What's the square root of, well, the negative square root of 16 would be negative 4. And what if we look at the square root of, let's say, 16 over 100? Remember, we can rewrite this to say the square root of 16 and the square root of 100, just like we're taking something to a higher power. We know the square root of 16 is 4, the square root of 100 is 10, so this is 2/5. That's simplifying. Now, can we do this, however? Could we have like the square root of negative 4? Well, no, we can't, because there are no two numbers we can multiply together, or no number we can use as a factor with itself to make negative 4. If we have negative 2 times negative 2, that's positive 4. And if we have 2 times 2, we get positive 4. There's no way for us to make negative 4 by taking a number and using it as a factor of itself. Okay? So, we have a lot of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 1/4 is perfect square. But what if we don't? What if we don't have that? If we have something like the square root of 3, well, in a situation like this, we really kind of have to use a calculator to determine what's going on here. So, because we can't work this out. So if we took, let's see, the square root of 3, and we put this into a calculator, we'll get 1.7320508, blah, 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 blah. So when we're thinking about these things, we would say that the square root of 3, this is not a rational number. Reason being is because this decimal goes on and on and on and on and does not terminate. However, when we look at something like the square root of 4, we know that's 2. This is what we determine and call a rational number. So, a little bit more on exponents are coming. We're going to be looking at next the product rule and quotient rule, how we set exponents and square roots, how we can use the product and quotient rule to simplify square roots. We're going to be looking at a lot of factoring here coming up. So hopefully this helps you with square root problems, and I will see you in the next video. Bye.